So question 3, I've got a diagram of the system here. We've got a particle which passes the point O at time t equals 0 and travels according to this velocity equation in time t. In part A, we've been asked to show that p comes to rest when t equals 3. So if this is our velocity equation, sub t equals 3, and we get that v is equal to 15 minus 9 minus 6, which is indeed 0. So there's rather quickly the answer to part A. Part B. Find the magnitude of the acceleration when t equals 3. Well, as you've probably guessed, this is not a constant acceleration question because the velocity is not constant. It's dependent on time. So to find the acceleration, we have to differentiate. A is equal to dv dt, which is equal 15 differentiates to 0. This becomes negative 2t minus 2. So now we sub t equals 3. Negative 2 times 3 is negative 6, and that's joined by negative 2, so the answer is negative 8, or the modulus of A, the magnitude of A, is equal to 8, and that will be your answer. So in part C, we've been asked to find the total distance travelled by the particle p in the interval 0 up to 4. Now, we've got a bit of a danger problem here. We've got that the particle stops its motion at 3 and then travels the other way. It's passed O, it's come to rest, and now it's coming back. So we're going to have to treat the distance in two separate sums. But what is the distance? Because we've only got the velocity. Well, the distance is the integration of velocity. We won't have to worry about c's because we've got limits here. So when I do the integration, I'm not even going to write plus c. So I can say that s is equal to the integration of v dt, which is equal to, let's just integrate this up. This is 15t minus a third t cubed. Just check that works. Yes, it does. Take away t squared. Check that works. Yes, it does. As I said, I'm not going to even write c. So the total distance will be the distance travelled from 0 to 3, which is expressed here. And then the second part of the journey from 3 to 4, the same equation with the limits now t equals 3 and t equals 4. Now, as I want the total distance, I'm not really caring in what direction this is going. So I've put modulus signs round our two parts of the journey because I want distance, not displacement. Displacement would roll back on itself, decreasing itself as the particle moved back towards 0. I'm after distance. So let's work these out separately. So 3 going into here, we get 45 minus 3 cubed divided by 3 is 9. Take away another, 9. And substituting 0 in here, this will give us minus 0. So it'll be the modulus of that plus the modulus of 4 times 15 is 60 minus 4 cubed is 64, so this will be negative 64 over 3. Take away 16. And we're going to be taking away our result from here, which we might as well work out. 45 minus 9 is 27. So this is equal to 27. So keeping the modulus just for the moment, we've got 16 minus 27, which is 17. And we're taking away 64 over 3. And if you work this out, you will get the answer of 94 over 3. And this will be in meters. And that's the answer.